Alright, so now it's example time. So in this first example, we need to graph each exponential function using table values or graphing technology. Try to use, try to do your actual graphing using table values before using graphing technology. It's important to know how to graph these. Hopefully you know how to input values to determine what those values would be, but it's always good practice. So for sure try the first one using the table values, and the second one we can use technology, okay? So when we do this, we're going to also identify the domain and the range, the x-intercept and the y-intercept if they exist, whether the graph is increasing or decreasing, and then finally we'll state the equation of the horizontal asymptote. So we'll scroll down here. So our first one here, we have y is equal to 3 to the power of x. Okay, and so first off, we're going to graph this. So I'm going to create my nice table values here. So we have x and y. Alright, so we're just going to choose some nice easy values. So typically whenever you graph a normal function, we always start with some nice values like -2, -1, 0, 1, and 2 if you want to go that far. Alright. This way we get 5 values will give us a pretty good idea of what's going on, so that'll be pretty nice to go with there. So now what we're going to do to find out y is we're going to input, we're going to substitute -2 in for x for that first one. So we'll have 3 to the -2. If you guys either put that into your calculators or if you guys know what that is, the negative there will flip it, so it'll become a fraction, and then 3 squared is 9. So 3 to the -2 is 1 over 9. Then we'll have x is equal to -1, so we'll have 3 to the -1. That will simply just flip it, so we have 1 over 3. When x is equal to 0, we have 3 to the power of 0. Any number to the power of 0 is just 1. Then we have x is equal to 1, so we have 3 to the power of 1, which is simply just 3. And then finally we have 3 squared, which we should hopefully all know that is 9, okay? So here's table values. You guys have lots of practice inputting values in for x or for y to find out, what those other values are. So hopefully we're good at graphing, but that's essentially how you go about getting those table values. So input those functions. There's going to be some examples where we have, it'll be, say, 3 to the power of y is equal to x. So in that case, you're going to put in nice values for y and then determine x, but it'll essentially be the same process. Just watch what variables you're using here. So here we're given that it's 3 to the power of x, which is why we chose to put input values for x, okay? We'll be more or less looking at that more into the next sections, okay? So now let's go ahead and start graphing this. So here our x values they range from -2 to 2. So what we can do is 1, 2, 3, 4. We'll have -1 there. -2, 1, and 2. Okay. Or if you guys want to, you guys could have done smaller values just to see what is going on there. If you guys make it smaller, you'll kind of see what it looks like a little bit, maybe a little bit more realistically without having that stretch there. But this is fine here. And then we go up all the way up to 9, so we'll every 2 lines will go up 2 for our y-axis. Right, so -2, -4, -6, -8. Alright, and so I think I've mentioned this before, it's always very important to label your spacing of each, little tick mark there. That way I wouldn't, there's no chance for me to guess, how would I know what each spacing is, so it's very important to label that, okay? So our first point there, we have -2 and 1 over 9. So when x is equal to -2, we have 1 over 9. That's going to be really close to that x-axis there, so I'm just going to put a little dot there. When x is -1, we have 1 over 3. So it'll be, again, pretty close there. It's going to be a little bit of a hard graph, especially using my writing pad. Alright, so the next one is 0 and 1. Then we add 1 and 3. And then 2 and 9. Alright. Then from there we can connect those points. I'm going to try my best. And don't forget your arrows at the end. And that should essentially what our graph should look like. And let's label that, so that is y is equal to 3 to the power of x. Alright, so graphing, I think, you know, we've been doing this for how long? Hopefully we've got this graphing business all down pat, so that'll be awesome there. Alright, if you guys have any questions, for sure we'll go through some more examples, but after this, if you guys feel pretty confident, start using your graphing calculators. The biggest thing though is I want you to feel confident with putting those values in and being able to find out, or I guess be able to graph it on your own, okay? So now we need to, now that we've graphed it, now we need to identify all of those wonderful values that I asked you to. So our first one here is we need to identify the domain and the range. So here our domain, oh, that's a pretty sad looking parenthesis there. So here we have that x is an element of all real numbers. So x will keep on going in the left direction and the right direction, so that is great there. Then we have our range. And that one, just like we stated before, typically they're all pretty much the same unless we apply any transformations, which we're not going to look at yet. So here we'll have that, we have y such, and sorry, this should be up here as x such that, x is an element of all real numbers. And here we have y such that y must be greater than 0, where y is an element of all real numbers. Alright. So sorry, here I'll fix it up there for you guys. So we have x such that x is an element of all real numbers. Okay. I know that Miss Windrum, she kind of wrote your domain and range a little bit differently, but especially once I know you ladies are going on to post-secondary, this is definitely how they're going to be looking for you guys to state your domain. So your domain and range, so you'll say your parenthesis x such that x is an element of all real numbers. Okay. Next one for B here, we need to look at the x-intercept and the y-intercept if they exist. So remember, your x-intercept is where does it cross that x-axis, and as you guys notice, your y values there, you'll never have y is equal to 0. So that also in itself is saying that there is no x-intercept. Remember, your x-intercept is when y is equal to 0, and if y cannot be 0, stating from your range, then obviously you can't have an x-intercept. Okay, and our y-intercept, so that is when x is equal to 0. So looking here from my very nice graph, that one there, or we can also use our table values here, we know that your y-intercept is at 0 and 1. Okay. C here, we're going to be talking about whether the graph is increasing or decreasing. Remember, that's when we're reading the graph from left to right. So if you guys notice here, our values start off very small for our y values, and then as we move to the right hand side, they continually get larger and larger. So what is happening here is that our graph is increasing. Or if we're going to use our definition there, we could say that this function here has an exponential growth. Maybe we can put that in brackets there. Alright. So it has some growth there. That's what's happening with our graph there, okay? And D, our last one there. D is asking for the equation of the horizontal asymptote, and that one, it stays the same here, and if you guys looking at your table values, it goes from 1/3 to 1/9. Remember I said that we can never have that, we can never have a value at 0, so here our horizontal asymptote, I'm just going to put HA there, and that is y is equal to 0. So notice how that didn't change from what we stated above. Okay, so as long as there's no actual changes, we didn't do any translations or stretches, which we'll look at the next section, these for the most part should stay the same. Okay, so that is that one. So now let's move on to the next one, so number 2 here. And for this one, you guys are more than welcome to use your graphing calculators. You guys have table values on there. So if you guys input this function into your graphing calculator, create a table of values. It's always good to write some down, so let's write some of those ones down here. So we'll go with -2, -1, 0, 1, and 2. If you guys do this using your calculators, your table values will have all these values here. Although I believe it gives it to you in decimals, which if you guys use decimals, that's absolutely fine. But if you guys do it by hand, you guys can kind of see what's going on here. So when x is equal to -2, we have 1/3 to the power of -2. using your either into your calculator, or if you guys know those rules, the negative will flip it, so it will become 3 squared, and what we have there is 9. Then we have 1 over 3 to the power of negative 1. That is equal to 1. And if you guys probably have this from your graphing calculators there. Then we have 1 over 3 to the power of 0 is equal to 1. 1 over 3 to the power of 1 is 1 over 3. And 1 over 3 squared is equal to 1 over 9. So I blasted through that, but you guys should have those values on your graphing calculator. But I kind of went through the steps there a little bit, how to quickly determine those, but that you can describe from your table of values, or if you guys tried it out on your own, that's essentially what our kind of little process there is going to be, okay? So from there, now that we got some values down, or if you guys had them from your graphing calculators, we can start graphing now. And here our values are going from negative 2 all the way up to 2. So we could, once again, graph it just like we did, or label it the same way. So every 4 tick marks, I'm going to make it at, it's going to, each space there's going to be a 1. So that'd be a positive 1, and 2. And then here we're going from 9 to 1 over 9. So we'll, once again, going through the y, each tick mark there will be 1, 2, 4, 6, and 8. Alright, then from there we can actually begin graphing, so make sure, biggest thing, make sure you label your spacing so I know that not every single one is just either 1 unit, or maybe, I don't know if those, who would guess, maybe every 2 lines would be 1 unit, or, so make sure it's very important to actually label that spacing on your graph, okay? So now we're at, let's graph some values here. So we have negative 2 and 9, so find negative x at negative 2, go all the way up to 9 there. So there's our first dot there. When x is negative 1, we're at 3. When x is 0, we're at 1. And when x is 1, we're at 1 over 3. And when x is 2, we're at 1 over 9. So it's teeny tiny, going to look pretty close to that graph there, or to that x-axis. So from here on out, we will connect our dots. Oh, yikes. Try and get as close as you guys can to that line there, or to your dots. It's a little bit harder using this wonderful technology, but hopefully it should look like a nice smooth curve approaching the x-axis, and don't forget your arrows on each end. Okay, and that is y is equal to 1 over 3x to the power of x. Okay? So that's that one there. For the next one, maybe I'll switch over quickly to, we'll do a third video. These next two will go by pretty quickly. We're just going to create the equations, and there's a nice little trick there that I'll show you guys, so that one won't take too long, okay? So I'm going to pause it, and we're going to go to video number 3.